Hello everyone. Hello lovely students. Welcome back to this video session. Hope you all are doing great in your life. My name is Ashwant and today I have got a really exciting math lesson for you all. Want to know what's that? Then please don't skip and make sure to stay with me all along till the end. Here we go. So for today's session, we have got this question and we have to find the range of this functional expression. I request you all to pause the video, read this question carefully, and try to solve it on your own. Alright, now let's solve this question with me. And let's rename this functional expression using fx. So we have fx is equals to cos square x minus 4 sine x plus 20. And I just want to say that we have done this type of questions, so many questions in our previous sessions as well. And this is quite different from those one. And the only difference is many of you might have guessed it, but now that instead of a single trigonometric function, we are having cos x and sin x both together here. So what we can do here is we can use the identity cos square x and sin square x plus cos square x plus sin square x is equals to 1. So using this identity, we can convert this expression in only one trigonometric function. So we can write fx is equals to, in place of cos square x, we can write 1 minus sin square x minus 4 sin x plus 20. Okay, so we have a negative sin square x, and then we have a negative 4 sin x, and we have a 21. Now this expression is very similar to a quadratic expression. Okay, many of you might not be able to see it as a quadratic expression. Well, don't worry. Just substitute sine of x is equals to t, and you'll see here that we have a negative t square minus 4d plus 21, because for sine x, we can put t. So this is a quadratic expression, and we'll use the square completion process, because whenever we come across a quadratic expression and we need to find the range of a quadratic expression, it is advisable to make it a perfect square. Now, how to make a perfect square, I have discussed in detail in my previous video. So to those who are watching this video session for the first time, I request you all to please watch my video session, my previous video session. You will understand in a much better way. Well, get back here. So the formula or the logic that I have taught in my previous video is, whenever you come across AD square plus BT. So this is a quadratic expression. I have not written the constant because to make a perfect square, the variable portion is sufficient. So we have A times T plus B by 2A whole square minus B square upon 4A square. Okay, so only we have to figure out the values of A and B. So for this situation, okay, negative t square can be further written as negative 1t square, and negative 4t we can write as plus and minus 4t plus 21. So the value of A is negative 1 and the value of B is negative 4. So A times t plus B by 2A whole square minus B square upon 4A square. Okay, and we simplify it. So we have negative 1 and t, this negative will get cancelled out, and we have t plus 2 whole square with a negative sign, and this will be your 16 by 4, and this will be your 4. Now we back substitute the value of t, which is sine x. So we have sine x plus 2 whole square minus 4. So fx is negative 1 into sine fx plus 2 whole square minus 4. So the expression that is given originally as cos square x minus 4 sin x plus 20. Okay, and we did some modification. We use the square completion process also. Okay, no, let me just fix this stuff. Okay, so we did the square completion process also, and we have this fx as negative 1 into sin x plus 2 whole square minus 4. Now this is a perfect square form. Okay, now we'll find the range of this fx. That looks a bit complicated and scary, but don't worry, we'll do that. And we'll use the modification process for finding the range of this functional expression. We'll start with the very basic trigonometric function sin x. So the range of sin x is close -1 to close +1. Okay, now we'll modify our basic functional expression at every step. You'll see how I'm doing that. So you add sin x plus 2. You add 2 to sin x. So to get the new range, you add 2 to the left-hand boundary point. So you get 1, and to the right-hand boundary point, when you add 2, you get 3. So sin x plus 2 comes out to be 1 to 3 and closed from both sides. Now, in my previous videos, I have discussed in detail about how to find the range of a complicated functional expression from a given basic functional expression, where we modify the given basic functional expression at every step. I have discussed in detail. So once again, I request you all who are watching this video session for the first time, please watch those video session. You'll understand in a much better way. Well, it gets back here. Okay, now we square this. Okay, I don't know why it's happening. I think the page is, yeah, the page is finished. Okay, no, doesn't matter. We'll write on the left and the right side. So we have sin x plus 2, and now we'll do the squaring because we have a square here. Okay, and when we do the squaring, we have sin x plus 2 whole square. Okay, so we'll have to square 1. 1 square is 1, and 3 square is 9. Okay, I have discussed in detail in my previous videos about finding the range of various types of functional expression. Okay, now we'll multiply with a negative sign. Okay, I'm using a green pen now. With a negative sign, you multiply sin x plus 2 whole square. Okay, so you'll multiply the left and the right hand boundary point, and they will be reversed. So we have -9 to -1, and then you add -4. Okay, so when you add -4, so you add -4 to the left-hand boundary point, so it will be -13, and it will be -5. And this is your fx. Okay, so we got the range of fx, and we did it. Okay, so the range of fx comes out to be close -13 to close -5. That's all. So this was all about today's session, and I did my best to make you all feel comfortable and happy. If you like my video, then please share it to your friends and loved ones, and make sure to subscribe my channel and hit the bell icon to get the notification of my next upcoming video. See you all, my lovely friends, in my next upcoming videos with more exciting and a lot of awesome questions. Till then, bye bye, stay safe, and have a nice day.